to prevent slipping between the two. First, you get into the free body diagram. There's no other way. You have to get the free body diagram. They're in contact. N1. Here N1 will act. M2G. M2G sine theta. M2G cos theta. Even this N1 also you should resolve. Or better write together, no? So let it be N1 plus M2G sine theta. Similarly, N1 cos theta. There'll be also normal contact between the triangular wedge and the inclined plane. And the weight of this. Okay, no. There's no slipping. So tell me like how the friction force. So in exams, they may ask you very simple, the direction of friction force acting on the block and the wedge. The level of questions can be like this here. So no, how to check that one? So look at the pseudo force. How pseudo force, let this have acceleration. Together they're moving. So how do they move? So they should move along the incline. So the acceleration of the system should be in what direction? Should be like this, downward. Then you put a pseudo force. Pseudo force, you just show thick arrow. Then component of this pseudo force will act vertically up. Other component will act in this direction. So then no slipping between them. So therefore the friction on this inward direction should be acting. I need some other brown color. So what is the direction of friction? The direction of friction should be like this. The friction on the inclined plane on the triangular wedge should be in this way. And there's no slipping if telling. Find the acceleration of the wedge. Wedge means this triangular wedge here. If there's no slipping between them, it's what is telling. Able to understand? So now, so this friction will become internal, no? Will become internal to the system. So what are the forces that are acting along the incline? N1 plus M2G sine theta. And component of N1 will also act. You take this block and triangular wedge as one system. And in the ground frame, you are doing it. So these two forces will be perpendicular. Component of this, component of will be equal and opposite. So what we should do, component of N1. So you resolve this, this will be theta. So what do we get? This one, N1 sine theta will cancel out. M1G sine theta and M2G sine theta. And what is the mass of system? M1 plus M2. So what should be the acceleration? Should be G sine theta. Individually on each block, you try and solve it, or directly you treat this M1, M2 as one system. Then this, what will happen? This N1 and N1 will become in. This N1 is what I'm showing here, component. Able to understand? I'll resolve it, no? So this will become internal. This friction will become internal. N2 and this will be acting internal. So what are the forces that are acting? M1G sine theta, M2G sine theta. So what should be the acceleration of system? The part A of the problem should be acceleration should be equal to G sine theta directly. So here what we are doing, N1, F, N1 and F will be internal forces for that block and triangular wedge. Okay, there's the initial part. Then find the friction force between the block and the wedge. Even in the above case, also find the normal force between the two. He's asking what is that friction? Okay, how to bring that friction, you know. So we know acceleration of this block now. So who will accelerate it? This friction only. So in the directly in the ground frame, we can take it. Or in the, you stand on this triangular wedge, component of pseudo force should balance this friction. I think I don't want to draw or one diagram. I'll draw it. This is accelerating. This is a block M1, M2. Pseudo force M1A. The friction force will be acting. The component of pseudo force will balance friction force here, and we know value of A. So let this be, I think this will be theta. So F should be equal to M1A cos theta minus U, right? So this will be, what is A? G sine theta cos theta. Substituting A equal to G sine theta. I got that particular. Is it a static or kinetic? It should be static. Okay, this is about, is asking normal reaction. So what about normal reaction? N1 plus M1A sine theta minus M1G equal to this one. A equal to G sine theta. So M1G okay, this will be the normal contact. Assuming there is no friction between the block and the wedge, calculate the time in which the block will hit the incline. I think some mathematics is bringing into the picture. Okay, now I think totally we should little bit, let's come out of, we'll discuss the problem when there is no friction here. What are the things here only? What should be the, find the minimum value of quotient of friction between the block and the triangular wedge so that no slipping occurs, if they ask you. What is the maximum permitted limiting friction? Mu s n1, and you know n1, substitute and try to solve, you'll get the value of mu s. And that mu s n1 should be equal to what? M1A cos theta. I think like this, you can calculate the permitted maximum, that one for which no slipping occurs. They may ask you this mu s also. Okay, let's come for the third part of the problem. I need. This is M1, M2. As usual, so show that forces here N1. This M2G, the forces acting here will be N1 plus M2G sine theta. Perpendicular to incline also forces acting. Let's not bother about that one. So let this be the acceleration. Then the pseudo force, you take pseudo force like this. M1A, component of the pseudo force will act here. So let's calculate now. First, what is acceleration? Same G sine theta or any other value? It should be G sine theta only. Acceleration should be called G sine theta. Then acceleration of the block relative to the triangular wedge. Let it be AR. So shall we calculate now what is AR is equal to? AR should be equal to A cos theta, and A is what? G sine theta. This will be theta. Tan theta equal to H by L. Let L be the length. So L equal to H cot theta. Then what is L equal to? AR T square by 2. So T is equal to 2L by AR. Let's substitute all the values. AR H is L is H cot theta. That is again same thing. This N1 will become internal. The previous problem, what we had a discussion, this N1 will become internal to systems. What are the only forces that are responsible for the motion of the block and this particular thing? Okay. But sir, this block will be moving with respect to the wedge. Then still can we apply? Earlier it was at rest. Now it is moving. No, in fact, so still can we apply? Still can we apply? But this block can also move along y-axis. No. Previous also it was moving here. Now with respect to this, it will be moving horizontally. So still what all the discussion what we are making, is it applicable in the third case or we should discuss separately? Anybody? I just made discussion. I wanted you to really think on this one. Shall we pick up the same A or we should calculate the acceleration of this?
Calculate.
We should calculate. You cannot proceed like this. It was earlier there was no relative motion. There is a relative motion between them. If there's a relative motion, how can you treat this as one system? Not possible, no. When you can treat when you treat this as one system, both will have common acceleration. No, there you cannot make this as one system because with respect to wedge, the block is moving. This is what we may the particular questions. What when you may get options of like this, you may feel you have done everything right. So what went wrong here? They are going to have different acceleration. Then how to work out this one? So I think I'll take it out from here. Small background thinking is needed. Okay, fine. So here is what this particular thing. So in fact, this M1 will have acceleration. How to calculate now? So I'll call this is some A naught. Okay, I don't know what is A naught. We are supposed to work out here. If we get A naught, then we can solve the problem. So what is N1? We don't know. In that N1 and this N1 are different. That's the only thing is what you should understand here. Nothing big here. Okay, I'll proceed like this here. N1 plus M2G sine theta equal to M2 A naught will write it. Then along y-axis, will they lose contact? One more thing. M1 and M2 will they lose contact? No, there won't be relative motion along y-axis with respect to these two here. With respect to triangular wedge, it will be moving horizontally, but there won't be relative motion. So therefore, with respect to triangular wedge, this block will be at rest. So what this person says, block, I think, okay, since the relative motion is there, no? Along y-axis, what we can write it, N1 plus M1 A naught sine theta M1G equal to 0. What are unknown things? N1 and A naught. Solve this, you'll get expression for A naught. This is for wedge. This is for the block. Agreed? Okay, let's get into anybody value A naught. We can
2mg sin theta by m plus m sin square theta.
2 mg. Masses are different, no? M1 plus M2.
Sir.
Yeah, I'll add that. 2 mg sin theta by M2 plus M1 Is that okay? That's what you said?
Yes, sir. Yes, sir.
Yeah. Okay, this is a naught. Now you got a naught. Now you calculate AR. What is AR equal to? A naught cos theta. Now write it. L is equal to AR T square. And again, what is tan theta is equal to H by L, or L equal to H cot theta. Substituting this equation 1, 2, 3, and 4, we'll get the required answer. I have answer. You verify later on, huh? You check the advance. We don't have any questions till now. The condition like this. They asked many wedge constraints, but we don't have any question of this kind. Huh? That's why I just picked up this one. What are other things left over? What should be the minimum value of mu between M1 and M2 so that there won't be slipping will occur? That also you try to work out one so that different things will be there. What are the, can you stop here? No, no. Just I may test you with some other ideas related to this. Let's have a small discussion. No, let's not write any equation. It become very lengthy again.